All right, so today we're talking about relations. Um, so to represent a relation, a coordinate system is formed by intersecting of two number lines with horizontal axes and vertical axes. So let's just recap what the coordinate plane is. So we have our y-axis, we have our x-axis, okay? We have our 0, 0 where they cross, and that is called origin. Then we have our, the whole thing's called a coordinate plane, and then each point is named by an ordered pair. So your point and then your ordered pair. Remember, ordered pairs are listed in parentheses. For example, 2, comma 3, your x, and then your y. Okay? Let's see. The x value is called the x coordinate, and the y value is called the y coordinate. A set of ordered pairs is called a relation. A relation can be represented in several different ways, as an equation in a graph, with a table, or with mapping. So let's take a look at those. So a mapping illustrates how each element of the domain is paired with an element of the range. The set of the first numbers of the ordered pairs is the domain, or the x's. The second number of the ordered pairs is the range of the relation, the y's. This is mapping represents the ordered pairs. So if I had these ordered pairs, I would take all of my x's and I would say -2, -1, 0, 1, 2. Then I would do all of my y's. But if you'll notice, I have 2 number 4s, so I could just list that one time, remember? So 4, 6, and again, I have 8. So 8. Then I can put what they go with. So -2 goes with a 4. -1 goes with a 4. 0 goes with the 6. 1 goes with the 8. And 2 goes with the 8. Okay? So that is a relationship, or a mapping. Let's see. So if we take a look at it, we have ordered pairs 1, 2, -2, 4, 0, -3. That is represented as ordered pairs, or a list. We could put them in a table. That's how you would represent those ordered pairs in a table. We could graph them on a coordinate plane. And we could show them in mapping. Okay? The x value of a relation are members of the domain, and the y values of the relation are members of the range. Okay? So the domain would be -2, 1, 0, and the range would be -3, 2, 4 in that example. So let's take a look at this example. It says, express the relationship between 1, 1, 0, 2, 3, -2 as a table, graph, and a mapping. So first a table. So I would set up a table. I would say x, y, and then I would list them all out. 1, 1, 0, 2, 3, -2. Okay? Then I would graph those, and that's my graph. And then my mapping, I would put 1, 0, 3, and then 1, 2, -2, and then put the arrows where they go. Okay? Meaning 1 goes with 1, 0 goes with 2, 3 goes with -2. Okay? And then it says to determine the domain and range of the relationship. So the domain would be 0, 1, 3, the x's, try to go from least to greatest, and then the range, -2, 1, 2. Again, least to greatest. Those are my x's, those are my y's. Okay? All right, you can pause the video, try this one on your own, and come back and see how you did. All right, so express the relationship of -2, -1, 3, 3, 4, 3 as a table, a graph, and a mapping. So first the table. I would have -2, 3, and 4, and my y's is -1, 3, and 3. So there, done with the table. Then I would graph those. -2, -1, 3, 3, and 4, 3. Okay? Then I have my mapping. -2, 3, 4, and -1, 3. And then I would have -2 goes to -1, 3 goes to 3, and 4 goes to 3. Okay? Now I would determine the domain and range. So the domain would be -2, 3, 4. And the range would be -1, 3. Okay? And that's how you'd answer that problem. All right. So in a relation, the value of the variable that determines the output is called the independent variable. The variable with the value that is dependent on the value of the independent variable is called the dependent variable. The domain contains values of the independent variable. The range contains the values of the dependent variable. Okay? So basically what that's saying is that the independent variable, or the independent, is going to be the domain, which is all of your x's, and the dependent variable is going to be all of the y's. Okay? So the y's are dependent upon the x's. All right. So identify the independent and dependent variables for each relation. So the dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. The number of tickets sold is the dependent variable because it is unaffected by the money spent on decorations. The money spent on decorations is the dependent variable because it depends on the number of tickets sold. Okay? B. Generally, the average price is going to the movies is steadily increased over time. So time is the independent variable because it's unaffected by the cost of the movie tickets. However, the price of going to the movie is dependent variable because it is affected by the time. Okay? All right. So a relation can be graphed without a scale on either axis. These graphs can be interpreted by analyzing their shapes. So for example, if I have the graph below represents the height of a football kicked, or after it is kicked downfield. Identify the independent and dependent variables for the relation. Then describe what happens in the graph. So I look at this graph, it has height and time. As time goes, it gets higher, and then of course it has to come back to the ground, so it goes down. So the dependent variable, or the independent variable, is your time, okay? And the dependent variable would be the height, okay? So the football starts on the ground when it's kicked, it gains altitude until it reaches maximum height, then it loses altitude until it falls to the ground. And that's how you would answer that problem, okay? So you're just describing the graph. The graph below represents the price of stock over time. Identify the independent and dependent variable for the relation. Then describe what happens to the graph. So the independent variable is time, okay? Because time, the price is dependent upon the time, okay? So the price is my dependent, okay? And I could say the price increases steadily, then it falls, then it increases, then it falls again, okay? And that's how I would describe that graph. All right. Okay. So here are a few. Again, you could try these on your own and then come back when you're done. It says identify the independent and dependent variable for each relation, then describe what's happening in each graph. So the graph represents the speed of a car as it travels to the grocery store. So the independent would be time, okay? Where the independent would be time. And the dependent is going to be speed. Okay? And then I have to put what the graph is doing. Okay? So I could put the car starts at a standstill. Okay, that's here. And then it accelerates. That would be this part. Okay. Then it travels at a constant speed for a while. So constant speed. That would be this part. And then it slows down to a stop, which would be this. Slows to a stop. Okay? All right. Number 2. The graph represents the balance of savings account over time. So the independent is going to be time, and the dependent is going to be the account balance or the balance, because it's dependent upon the time. All right? And then I can say, the balance has initial value, because it doesn't start at 0, it starts up here. So it starts out with a value, and then it increases. Okay. It stays the same. Then increases. And then it decreases to 0. Okay? All right. And then the third would be the graph represents the height of a baseball after it is hit. Okay? So my independent is going to be time. My dependent is going to be height. The height is dependent upon the time. All right. So I can say the ball is hit at a let's say certain height above the ground. Okay, we didn't start at 0, we started up here. So it's hit at a certain spot above the ground. Then the ball increases in height until it starts to decrease. Decrease to the ground. Okay? So it increases, then it starts to decrease until it hits the ground. All right, and that's relations. If you have a question, please don't hesitate to ask. Otherwise, your homework's posted. Have a great day.